Just for a second, look around you. Pretty simple, right? You just open your eyes and there's the world, all in one perfect, seamless, high-def picture. But what if I told you that what you're seeing is mostly a brilliant illusion, that it's being pieced together by a hidden autopilot in your brain? Well, today we're going to pull back the curtain on how that autopilot works and what it tells us about the mind-blowing connection between just seeing and actually thinking. And I want you to really, really think about that. We put so much trust in our eyes, right? They help us get around, read, recognize people we love. But that entire experience, it's all built on a pretty surprising secret. No, I'm not kidding. Hold your thumb out. That's it. That's the only part of the world you're seeing in true high def right now. Everything else, all that stuff in your peripheral vision, is actually super low resolution and blurry. Your brain is just an absolute master at hiding that fact from you, and that creates a huge problem it has to solve, thousands of times an hour. So how in the world is that possible? How can everything feel so crystal clear if we're only seeing a tiny speck of it in focus? Well, the answer is all about the way your eye is built. Everybody, meet the fovea. You can think of it like the super-powered 4K sensor in your eye's camera. It's tiny, but it's packed with all the good stuff. The rest of your retina, that's basically streaming in old-school standard definition. So only the light that lands smack dab on this little spot gets processed with maximum detail. Everything else is, well, it's fuzzy. So to build that big, beautiful, clear picture of the world, your brain doesn't just sit back and watch. Oh no, it's more like a super fast artist constantly darting that little high-res fovea all over the place, taking these tiny, ultra-clear snapshots of all the important bits. And then it stitches them together so fast and so flawlessly that you never, ever see the seams. And the way it pulls off this incredible magic trick involves one of the fastest movements your body can possibly make. Seriously, these little movements are the secret sauce to our entire visual world. They're called saccades. Think of them as tiny little ballistic missiles for your eyes. Once your brain launches one, its path is set. It can't be changed mid-flight. These are the things that let you read a line of text, glance up at a bird outside your window, and look back down without the whole world turning into a blurry mess. And we're not just talking about a few of these here and there. Nope. The average person makes over 100,000 of these every single day. And the craziest part? Most of them are totally unconscious. That visual autopilot in your brain is always on, always working. And these saccades pretty much come in two main flavors. First, you've got the reactive ones. These are your reflexes, right? That automatic, what was that? Glance when a pop-up ad appears or a fly buzzes past your ear. And then you have the voluntary saccades, the ones you actually control, like when you decide to scan a bookshelf. Both are absolutely essential. But here's where it gets really interesting. A system that's moving over 100,000 times a day at that kind of speed, well, it can't be perfect all the time. And guess what? It isn't. Yeah, turns out our saccades are what scientists call hypometric. Fancy word, but it just means they naturally tend to undershoot the target. So if you're trying to look at something 10 inches away, your eye might only jump 9.5 inches. It's a tiny, tiny error, but when you're making thousands of these movements, those errors should add up and make everything look wrong. And that is the million-dollar question, isn't it? If the very tool your brain uses to build your visual world is consistently making small mistakes, how does it keep everything looking so sharp and stable? How does it fix its own screw-ups without you having a clue? Well, the answer is just so cool. It's a process of constant self-correction. It's like your brain has this background autocorrect program for your eyes that's running 24/7. This whole process is called saccadic adaptation, and it's a perfect example of what we call neural plasticity. Your brain, specifically a part of it called the cerebellum, is constantly watching for those little errors when your eyes land, and it's making these tiny on-the-fly adjustments to the signals it sends your eye muscles, making sure you hit the mark perfectly next time. So how on earth do we even know this is happening? Well, scientists have this really clever experiment. They have someone look at a dot, and then a new target appears. As the person's eye starts to move to the new target, the scientists secretly jump the target to a slightly different spot. And because of this cool thing called saccadic suppression, you don't even consciously see the jump happen. So your eye lands where the target used to be, and your brain goes, whoa, wait a minute, we missed.
And this is where the magic really kicks in. After the brain sees this same error happen over and over again, it adapts. It literally learns. It starts tweaking that initial eye movement, making it just a little bit longer or shorter to compensate for the jump it now expects to happen. It's recalibrating its own software in real time, all without you feeling a thing.
Okay, so up to now, we've mostly been talking about the pure mechanics, the physical act of moving your eyes around. But we all know there's a huge difference between just looking at something and actually paying attention to it.
Come on, you've been there, right? You can stare directly at a page in a book, your eyes are moving, but you don't absorb a single word. And on the flip side, you can be staring straight ahead, but focus all your mental energy on something you heard off to the side. So, are these two things, moving your eyes and paying attention, totally separate? And what neuroscience is telling us is, nope, not at all. It turns out the circuits in your brain that plan and execute those little eye movements are deeply, fundamentally tangled up with the networks that control where you direct your attention. And that connection, well, it has some really wild implications.
And this brings us right to the heart of the research we're talking about today. Because if the system for looking and the system for attending are linked up, could you maybe train one of them to make the other one better? So to figure this out, researchers use that exact same target jumping trick we talked about. They basically put people's brains through an eye movement workout, forcing that saccadic adaptation system, that autocorrect, to work overtime.
And here it is, the big one. That purely motor-based training, just recalibrating eye movements, actually led to a measurable boost in people's visual attention. They got better at spotting and telling objects apart, even when they were forced to keep their eyes perfectly still. Get this, training the autopilot for looking also trained the pilot for attending. And this isn't just a neat science fact. The potential here is huge. As the researchers themselves put it, this could lead to whole new ways to help people with visual attention problems. Imagine that, using simple eye movement exercises to help train someone's cognitive abilities. It's a total game changer. It really makes you wonder, doesn't it? Our brain isn't just a bunch of separate parts in a box. It's this incredibly interconnected web. The simple unconscious act of looking around is tied to the very complex cognitive act of paying attention, which just leaves you with this one fascinating question. What other amazing connections are just hiding in there, waiting for us to find them?